to the cosine rule. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so we're going to start with the bad news. The cosine rule has a very nasty formula. A squared equals b squared plus c squared take away 2bc cos a. And second piece of bad news, you're going to have to learn this as it's not given in the exam. You will need to remember this formula exactly and be able to apply it. This all comes for, this is the rule for finding a missing side in a diagram. There are other versions of it. We can replace A with B and swap A's and B's around within all of this. We can swap the C's with the A's and so on. But this is the basic version. If you can learn one, you can set up every question using this formula. It all comes down to the triangle here, labelled in the same way as we do for the sine rule, where we have capital A opposite to lowercase a, capital B opposite to lowercase b, and capital C opposite to lowercase c. And we've got here the formula for finding a side. If you want, you can actually rearrange this formula if you want to find an angle, and you might want to learn this version as well. Cos A equals b squared plus c squared take away a squared over 2bc. That is if you are trying to find a missing angle in a diagram. But I would recommend, if you only want to remember one, you can always use this formula and rearrange it as you go whilst you're working through these questions. Okay, so let's see if we can use this formula to find the missing side in this triangle. Now, just to point out when we can actually use the cosine rule, the important thing is if you are wanting to find a side and therefore are using this version of the formula, you must know an angle and the two sides which surround it. If you know any other information, then you're not going to be able to use the cosine rule, because what we want is an angle with the two sides which surround it, and then we want to be able looking to find the third side. And so in this case we have all the information that we do need. It then comes to how we actually arrange the lettering for the diagram. Now the important thing here is the angle that we know. The angle that we know must be opposite to the side we want to find, because that is little a and capital A. And that is the most important thing, where the side that we're trying to find we will always label as A, and therefore the angle opposite it will be capital A. The other two sides, it doesn't actually matter which way around we label them, but we could call 5 little b, and then the angle opposite capital B, and side 4 centimetres we call that C, and the angle opposite it capital C. The reason it doesn't really matter is because B and C don't actually come into the formula in terms of the angles, and B and C, the sides, well, they are just always being either multiplied by themselves or multiplied together, and therefore the order doesn't actually matter. But what we're going to look at here is we're going to try and find out what our value x is. And so all I'm going to do is substitute in. So x squared equals b squared, so that's 5 squared, plus c squared, so that's plus 4 squared, take away 2 times, and it is important that we remember this is multiplication, so 2 times 5 times 4 times cos of 40. And the beauty of this method is that all of this can just be typed into your calculator exactly as it is. We don't actually need to do any rearranging at this point. So all we're going to do is type exactly that in. 5 squared plus 4 squared, take away 2 times 5 times 4 times cos 40, close our bracket, press equals, and we've got 10.358. Now, 10.358, that seems like quite a large number, and the reason, that is x squared. We always have to remember that this is x squared, it's not the actual length. We do need to square root that answer, and so we come back to our calculator, square root answer, and we actually get 3.218. And if we have a look at the rest of the diagram, 3.28 looks like a much more sensible answer to the size of length x. Okay, so in our next question, let's just check again. Do we have the criteria we set out previously? Well, we have an angle, and we have the two sides surrounding that angle. That is good. And the side which is opposite that angle is the one that we're trying to calculate. Therefore, this is all set up for the cosine rule. All we need to do is just check with these a's. So the side we want to know is little a, the angle opposite it is capital A, and then the other two sides doesn't really matter. We can call the 7b and the 9c. And now we can fill that information into our equation. So a, well, we just call that x at the moment. X squared equals b squared, so that's 7 squared, plus c squared, that's 9 squared. Take away 2 times b, which is 7, times c, which is 9, times cos of 100. So we'll just type all of that straight into the calculator. We get 7 squared plus 9 squared. Take away 2 times 7 times 9 times cos 100, close bracket, equals, so x squared is 151, so x squared is 151.880, but that is x squared, so we need to square root that answer. So all we need to do, root answer equals, and that's going to be 12.32 centimeters. And again, if we have a look at that, A is going to be quite a long side, as the 100-degree angle makes it longer than the 9 and the 7, but it's still a sensible result for that question. Okay, so next we're going to look at finding an angle using the cosine rule. And if we're going to find an angle using the cosine rule, this rule is very simple. In fact, we need to make sure that we know all three sides of the triangle. If we don't know all three sides of the triangle, we can't use the cosine rule to find the missing angle. So in this case, we've got all three sides, so we're going to be able to use it. And in the first occasion, I'm going to use the original version of the formula, just a squared equals b squared plus c squared minus 2bc cos a. And I'm going to show you how you can use that to find the angle on its own. Now the key thing, once again, is that we're talking about cos A, so therefore the angle we want to know must be called capital A, and that means that the side opposite it must be little a. The other two sides, just as in the previous, doesn't actually matter which way around we do it, but the really important one is this one, cos A. That must be the angle we're actually looking for. And therefore, all we're going to do is we're going to fill in all of the values we know. So we know that little a is 3, so we have 3 squared equals b squared, so that's 4 squared, plus 6 squared, take away 2 times 4 times 6 times cos a. We don't know what a is, so we're just going to leave it as that. And then this time we are actually going to have to do a little bit of working out. We're going to have to fill in all of the values that we've got. So 9 equals 16 plus 36. 2 times 4 times 6, well that's take away 48 cos a. And so then we're trying to isolate the cos a in this equation. Therefore, what I'm actually going to do is I'm going to add the 48 cos a to both sides, and I'm going to subtract the 9. So if I add 48 cos a, then I get 48 cos a equals 16 plus 36 take away 9. And finally, if I want to get cos a all on its own, well, that would be 16 plus 36 take away 9 all over 48. I've divided by the 48 here. Now, just like in everything to do with trigonometry, if we're trying to find an angle all on its own, if we're trying to find the angle, then we need to use the inverse. And so capital A is going to become cos inverse of everything we've got written here. Now, obviously, you could work out what 16 plus 36 take away 9 is. that's up to you, but because we've got the calculator, we can do it all on there. So let's do that. Shift cos, and we've got a fraction, 16 plus 36, take away 9, all over 48, close your bracket, and we get an answer straight out that x, the angle we were looking for, is 26.38. So x equals 26.38 degrees. Okay, so just before we move on to the next example, I just want to point out this piece of our previous working out. Cos A equals 16 plus 36, take away 9 over 48. Now, this is actually just the rearranged version of the formula that I showed you right at the very start. Because 16, well, that is b squared. 36, well, that is c squared. 9, well, that is a squared. So we have our b squared plus c squared take away a squared. And the bottom, the 48, well, that was from 2 times 4 times 6. So 2 times b times c. And so, if you want to use the rearranged version of the formula, which we have here, cos A equals b squared plus c squared take away a squared over 2bc, if you want to remember that one, you're saving yourself 2 or 3 lines of working out. But actually, if you're happy with rearranging formula, you're better off just staying with the original version of the formula. If you struggle a little bit with rearranging, it may be worth trying to remember this version just so you can put it straight into action. Let's have a look at what that looks like. In this case, we just need to check once again, do we actually have everything we require in order to use the cosine rule? Well, I know 1, 2, 3 sides of the triangle. We can use the cosine rule for this. And the key thing here, though, remember that x is the angle we are trying to find, therefore it must be called A in order to match with our formula, giving us that the 2 is the little a. The other 2 sides doesn't really matter, so let's call B 6 centimetres, giving us capital B over here, and 5 centimetres, call it C, giving us C over here. And then all we need to do is fill in our formula. So cos A equals B squared, so that's 6 squared, C squared, so that's 5 squared, take away A squared, which is 2 squared, all over 2 times 6 times 5, and we're going to need to find A, which means we need to use our inverse. So cos inverse of everything that we had written before, 6 squared plus 5 squared, take away 2 squared, over 2 times 6 times 5, and pop it in our calculator. Let's see what we get. So shift cos of 6 squared plus 5 squared, take away 2 squared, all over 2 times 6 times 5, close our bracket, and we get 18.19 degrees. Next we have a question where we're trying to find the size of an obtuse angle, x here. Now, if you've seen the video on the sine rule, you'll notice that seeing that there is an issue with the sine rule and obtuse angles. I just wanted to have a look at obtuse angles when it comes to the cosine rule. We've got, again, 3 sides of the triangle, therefore we can use the cosine rule to find the missing angle. But this one is the one that we want to find, so it must be called A, and then that makes the 9 little a. It makes any of the other sides B, so the side opposite, the angle opposite, B, little c, angle opposite, and then we've got cos A equals B squared plus C squared, take A squared over 2BC, and let's pop that in. So cos A equals B squared, so that's 5 squared plus 6 squared, take away 9 squared, all over 2 times 5 times 6. And if I want to get A, then I need to do the inverse of everything that we had previously. And so let's do that. Shift cos fraction 5 squared plus 6 squared, take away 9 squared, all over 2 times 5 times 6, close your bracket, and we get an answer for x of 109.47. Now in this case it has automatically come out as an obtuse angle. It's greater than 90 degrees, and therefore that's just a sign that with the cosine rule you don't need to worry about finding obtuse angles, they will be correct. Next we're going to do with triangles built on top of triangles, and also including a little bit of trigonometry that we could do. This question has a couple of methods to it, but basically I just want to use the cosine rule in order to find the length of x. But remember, if we want to find the length x in a triangle using the cosine rule, we must know the two other sides of that triangle and the angle in between them. Now at this point, using the cosine rule, we wouldn't be able to do it because we don't know this side here. So there must be a method for us to get there. And the idea is that what you will notice, we begin with a right angled triangle. And so we can actually begin this task with basic trigonometry in order to find the hypotenuse in here. So we've got the hypotenuse, we have the opposite, and we have the adjacent, and therefore we're going to use so, because we're not interested in the adjacent. So sine 34 equals 5 over the hypotenuse, and therefore the hypotenuse, quick switch here, multiply by the hypotenuse, divide by sine, and so the hypotenuse would be 5 over sine 34. I'm actually going to keep it exactly as that here. I'm not even going to work out what 5 over sine 34 is, because it's going to be easier for me to use that value straight into my equation. Because next I'm going to use a squared equals b squared plus c squared minus 2bc cos a. And in this case, remembering a must be the angle we already know, little a the side we want to find. The other two sides doesn't really matter, so that would be b, b, and c, c. And so a, we don't know, it's just x, so x squared equals b squared. Well, b is 11, c is the answer that we got up here, so that is 5 over sine 34 squared, take away 2 times b times, and again the length we got for c, sine 34 times cos 28 in this case. And all I'm going to do is I'm going to type all of that into the calculator. So 11 squared plus brackets 5 over sine 34 squared, take away 2 times 11 times brackets 5 over sine 34 times cos 28, and that comes to 27.263. So x squared 27.263, but we actually want to know what x is, so we must do the square root of that. So the square root answer equals 5.22 centimeters. Okay, and so to end, we come to the exam question, and this one came from AQA, and we were told the two triangular lawns shown, and wire fencing is needed for all 5 sides. Wire fencing is sold in 50-metre rolls. Work out the number of rolls needed. So the first thing that we need to just check here, where is it that we are going to be placing fencing? well, it's all 5 sides. So there's 1, 2, 3, 4 and 5. And so in order to work out how much fencing we're going to need, we're going to need to actually work out all of the different lengths. And so I'm going to begin with the top triangle, because that one is a straightforward right angle triangle. So I should just be able to use a bit of basic trigonometry in order to work out the different lengths in this one. And so let's start off with the side on the right hand side. So let's call this one, there's our opposite, there's our hypotenuse, there's our adjacent. And so in this case I want to find the adjacent and I know the hypotenuse, so I'm going to use cos to start with. So cos 40 equals adjacent over hypotenuse, so x over 100. And so this length A must be 100 cos 40. And 100 cos 40, if we type it into the calculator, 100 cos 40 is 76.60. 76.60. Now let's just check. I'll go one more decimal place, 604. I'm just going for more decimal places to try to be as accurate as I possibly can. So straight away I can fill in that value is 76.604. Now if I want to find the length at the bottom of that triangle, I'm going to need to use O and H. So that is going to be sine for so. So sine 40 equals x over 100. And so in this case the value here would be, actually let's change that to y as we've got a different side. So y would be 100 sine 40, and 100 sine 40 is 64.279. 64.279. Let's add that onto the diagram. And the reason that that one is quite useful is that now we can deal with the bottom triangle. We have this triangle drawn here, and now we have two sides surrounding an angle, and we want to find the other side, and those are the properties required for the cosine rule. So we've got two sides surrounding an angle and we want to find the angle opposite it, and therefore this must be big A, this must be little a, and then we'll have B and big B, C and big C. And so A squared equals B squared plus C squared, take away 2BC cos A, fill in all of the values we know. So A squared equals 64.279 squared plus 120 squared, take away 2 times 64.279 times 120 times cos 30. And here we can now put all of that straight into the calculator in order to get A squared, and helpfully we've still got 64.279 on our calculator, so this time we can actually just put ants squared plus 120 squared, take away 2 times ants times 120 times cos 30 and press equals, and we get 5171.66953, but that is A squared. We want just A, therefore we're going to have to square root that answer. That comes to 71.914. And so let's add that to our diagram, 71.914. Because if we are going to find the find how much fencing we need, then we're going to have to add together all of those answers. And so next, all I'm going to do is I'm just going to add each of those values together. So I've got 100 plus 76.604 plus 64.279 plus 71.914 plus 120, and that gives me 432.797. So 432.797, and that is going to be meters. And wire fencing is sold in 50-metre rolls. So how many rolls? Well, the last step here is I just need to see how many 50s it would take to make 432. Well, that means it would be 9 rolls to get 450 metres of fencing.